Thanks for coming. My name is Mikkel Mørk Hanhøj, and I'm a program manager in the Visua Studio team in Microsoft. I'm part of what we call the Azure Developer Experience Group. So our main responsibility is to create a good developer experience developing for Azure using the Visua Studio tooling that we provide. I, in particular, focus on the Visual Studio.NET experience. And the talk today is about getting started developing .NET Cloud applications on Azure using Visual Studio. So I'm going to do some introduction to how to easily get started and dive into a few sort of hot topics that we have right now. So Visual Studio in Azure is going to be the first thing we're going to talk about. I'm going to do a quick getting started demo of getting into Azure. And then I'm going to dive a bit into diagnostics and debugging in the cloud, where we have some great new features and functionality I want to show you, I want you to be aware of, because this is one of the places where we see you get great benefits of actually running stuff in the cloud as opposed to running in your local data center today. And finally, we're going to touch a little bit on containers and microservices being one of the also hot topics or new things we want to do, and how the cloud can help you leveraging some of the concepts and the technology we have there. So before we actually dig in, how many of you have production workloads running in the cloud today? Okay, only a few hands. Okay, how many of you have done things with the cloud, like learning, tutorials, testing? Okay, a few more of that. Okay, that's good, thanks. So Visual Studio and the Azure Developer Experience, what it's all about and what we care about when we want to help you as developers being successful with Azure, is to give you a great local developer experience for .NET. So sort of the goal state is that whatever you can do in the cloud, you can do locally. Like we have emulators for a lot of the Azure services that you can use on your machine. So whether you want to use Azure Storage or Queue technologies, if you want to do Service Fabric development, and then even containers, we have great integration stories for being able to do that right on your dev machine. You don't have to go to the cloud to do a lot of those things. I'm going to show you some of that today as well. Then it's about helping you to very easily get Azure set up and help you get your application up and running. It's one of these few click experiences, and you're there. But we also focus on, once you're there, you can easily integrate your application using Azure services. So building your application architecture around the different services that we have in Azure and make that easy. And then once you get to a certain maturity level, you want to make it easy to have continuous integration and delivery set up also in the cloud. So as your project matures and your application matures, you get sort of the full benefits of all the modern DevOps and the cloud agility and scalability. And finally, as I mentioned earlier on, the building diagnostics that just help you understand how your application runs and make that very easy for you. So there are the four things that we are that we put focus on, and four things you should probably be considerate about when you want to start putting applications into the cloud. First of all, you need your dev tools set up and ready for it. And when it comes to Visual Studio 2017, where we have a new installer experience, we have a workload called Azure Development Workload, which gives you all the tools and extensions and sets Visual Studio up so that you're all set and ready to go and start creating applications using Azure. Then there is some infrastructure in Azure or Azure resources that you need to have set up and you need to have provisioned for your applications to run there. So there are concepts around how those resources work in Azure, and I'll show you a bit of that. And deployment, getting the continuous delivery integration set up using Visual Studio Team Services, and finally, when we talk about insights diagnostics, we have Azure Monitor Application Insight and OMS as being the prime services of getting your diagnostics for your applications. So Visual Studio Installer, how many of you are running Visual Studio 2017 today? Okay, so most of you, have you all seen it? Tried it? Yeah, most have. So when you install Visual Studio 2017, we have this new Visual Studio Installer, which makes it very easy for you to set your Visual Studio environment up and gives you all the extensions and components that you need for your specific workloads that you want to work with. And in there, we have something we call the Azure Development Workload. And once you go and enable the Azure Development Workload, you get a lot of the tools and emulations that I mentioned earlier on. publishing features and stuff like that that you would need. And in most cases, and what I'm also doing typically, is I add the ASP and web development workload as well, because that gives me my container tooling and it gives me the ASP.NET web tooling that I need to create web applications as well. What the Visual Studio installer also supports is that you can have multiple instances of Visual Studio installed. So you can have Visual Studios that are set up with some workloads in one instance, another instance with other workloads. And we also have a new preview channel, if you weren't aware of that. And you can have Visual Studio Preview side by side with the current supported release. And the installer also supports those and helps you update and change the workloads there. So Visual Studio 2017, install the Azure Development Workload. If you are not on Visual Studio 2017, but Visual Studio 2015, there is an Azure SDK for .NET that you should go and download and install, and that will give you most of the features that you have in Visual Studio 2017 as well. I think it's actually all the features today. So resources in Azure. Azure has a concept called Azure Resource Manager, and Azure Resource Manager is sort of two things. The Resource Manager is a way of, it's a declarative solution to deploy and configure the resources you need for your application to run. So it's this consistent management layer across all of the Azure services we have. So it's the same way you configure all the different Azure services you can use. And we have tooling both in Visual Studio and VS Code to help you do that if you want to sort of do infrastructure as code. But also you can do this through the Azure portal, through all the APIs that we have, REST APIs, the new command line, Azure command line interface, Azure CLI, and PowerShell, of course. So the little graphic below here is just to show you that the different resources, when we talk about resources in Azure, so let's imagine you want to run a web application and you need a SQL server to back that web application. Now you would need some Azure resources to actually run that. You would need a database for your SQL server. For your SQL database, you need a SQL server and a database in Azure. And you would need what we call a web application or a web app to host your web application. So those are two of the resources you would need for that application to run in Azure. And the Azure Resource Manager is how you declare to Azure that you want those things and how they be set up and how you configure them. What's also part of the whole resource management thing is something we call resource groups. And resource group is basically just a way of coupled together multiple resources in sort of logical or operational units. What resource groups gives you is, I think what they're most used for, at least within Microsoft, is that it's just easy to delete a bunch of resources because you can just remove the resource group and everything gets deleted. But it's also a point where you actually assign access control, so role-based access control. So let's say I have a resource group with my web application and my SQL server in, which is just this one application I have. I can have different resource groups, and I can have different people with different kinds of access to those different resource groups. So I'm going to show you a feature later on about debugging and debugging in production. And one of the things we do to enable that feature is we can actually have production resource groups where you can just give developers access to only go and get those debug snapshots that we need for that feature. So as a developer, you don't need full control over the operation or the resources actually running production, but we can give you those specific access to those resources to just go and get what you need in there. So that was a little bit about Azure Resource Manager and how you set those up. Continuous integration and continuous delivery pipelines. So when you deploy things into Azure, so we have all the resources set up, and now we need to get things and deploy them in there. Everything in Azure has a REST API. So you can build your own tooling, and you can call those REST APIs to deploy things, and to get things. So if you need to get a database in there, you have if it's a SQL database, you have the usual, the service-specific way of deploying. So you can deploy a SQL database to an Azure SQL server the same way you would deploy it to any SQL server running anywhere. And the same with, for instance, a web application. You can use web deploy to deploy a web application into Azure, which is the same thing you would do if you wanted to deploy a web application to an IaaS server running in any other data center on-premise and not in the cloud. So lots of tools and lots of ways to automate deployment. And we also have Visual Studio Team Services as our cloud service. That is the product and the service that helps you do this and set you up to create easy continuous integration and delivery in the cloud. So the value add the Visual Studio Team Services gives you here, and which makes it very, very easy, is that we have predefined build and release definitions. So basically build workflows and release workflows to support the different Azure services and the different scenarios you have. I'm going to show you some of those as well during this demo. And you can also easily set up workload testing as part of your release pipeline. So release, run performance test, validate, and finally go and maybe swap environments and put your testing into production, however you want to do that. So Visual Studio Team Services is great for quickly putting you on this path of being able to continuously deliver on your application. And finally, the insights piece. There are two things we want to monitor when running stuff in Azure. We want to monitor, of course, the application, how it's doing, so to speak, how is my code doing, and then we want to monitor the Azure resources that we have running. And roughly speaking, if you want to monitor your application, we have application insights as a service running in Azure, which also has an SDK that you can go and bake into your code. I'm going to show you that as well, which gives you some great tooling to figure out how your application is running, where are the failures, and what you can do about those. And then we also have Azure Monitor and OMS, Operation Management Services, to help you monitor the resources. So that could be everything from when you run a web application in Azure, it's backed by something we call an app environment, which is basically CPU and memory and disk resources that your web application need. So you can go and monitor how much CPU and memory am I using on my app environment. Can I have multiple web applications running within that app environment and stuff like that. At the end of the day, this is still resources, it's still built by resources. You want to be efficient in using those resources, so it's important for you to still monitor those, even though you just want to run your application up there. So let's see how we can get from Visual Studio to Azure in 5 minutes or even less. So here I'm in Visual Studio 2017. And for this scenario, I'm just going to use ASP.NET, create a web application that's backed by SQL Server to show you how all that works and how you get all these things up and running in Azure. So an ASP.NET web application, let's just call this Web Application DEVintersection. And when I create this ASP.NET web application, let me just do an MVC. And what I want to do is I want to add individual user accounts. The only thing I want to do, the only reason why I'm doing this is because I actually need a SQL server to store my user profiles as well. So just make it easy to show you how I can get both a web application and a SQL server up and running. So Visual Studio is now creating my project. The web application project is pulling down some NuGet packages that it needs. And while it's doing that, let me just quickly show you. This is the Azure portal. Have you all seen the Azure portal before? Anyone never seen the Azure portal? Okay, so everyone's seen the Azure portal. Thanks, that's great. So this is my view in the Azure portal. I can create these nice dashboards where I can just share them with my colleagues. I can set this up to show different resources. And you can see on my left-hand side here, I have a whole bunch of resource group, which is just my logical grouping of the resources I have in Azure. And one of the resource groups already configured is the one that I've shown over here, where I show you the resources I have in this resource group. And as you can see, I have my app services, which is where I run my web application. I have my SQL database. And I have some bagging services that I need, the SQL Server, the app service plan that I just talked about. And I have some application insights set up. So this is a fairly common basic setup you want to run an application in Azure. There's an easy way to create this in Azure. And if I go and search for Web SQL to create a new service in Azure, what I get is I get these templates for setting up Azure resources for me. And there's actually one called Web App and SQL, which I use to just create the resource group I just showed you. So creating this, using this template to create my resources in Azure, I'm ready to go ahead and deploy my application in there. So now that Visual Studio has created my web app, an ASP.NET application in Visual Studio, you get this fine overview page in ASP.NET projects that sort of leads you through the steps of going into Azure. And some of the things that we focused on making very easy for you is trying to put these value-adding services into your application. So if your application needs to connect to other services within Azure and you want to use those and integrate in your application, we just made it very easy for you through this connected services thing. And one of the things we can do is we can set up monitoring the application through Application Insights. And you can get started for free, which is nice. Application Insights will be free. Running the actual web app is not free. The thing that sort of, there's a free and there's a paid tier of Application Insights. The free tier is basically limited by the number of events and telemetry and diagnostics you can store. All features is in the free edition. Then the strange thing is that some features require that much storage that you cannot run them in free edition, so you need a paid edition, so it's actually not free, but that's a whole other thing. But you can get started with the basics for free. Visual Studio is connected to Azure through my Microsoft account, as I have here, and you can see the Azure subscriptions I have access to. And I can go and I can create a new resource for this Application Insights, to connect my web into Application Insights, or I can use the one that I already configured. So let's go back here. So I'm going to just hook into the Application Insights resources that I already set up in Azure. And I can go and register for this one. And Visual Studio is now adding the required NuGet packages to my project. There's actually no code change I need to do to just get started with Application Insights. The base functionality is a set of NuGet packages and libraries that we are adding to the web application, and some configuration. So when your application runs, we just start picking up all the diagnostics information that you need. And this is pretty funny, it gives me 83% of App Insights. I don't know why it's 83 and not 82. But to get the last 17%, I need to click another button. This is fairly trivial, so let's click that button, and then we're actually at 100%. What we just did is we actually enabled the web application we've enabled the web application and Application Insights to pick up if I were to write traces in my code using System Diagnostic Trace. So as you can see from this guy, I can put in anywhere in my code, I can just write out traces using the System Diagnostic Trace, information, warning, or errors. And that will actually be picked up in Application Insights, and you will be able to see that in App Insights. So it's very easy for you to go and instrument your own code and get that along with all the other information that Application Insight picks up. So now I configured my application to be monitored with App Insights. And if I needed to use Azure Storage, I can easily attach. If I wanted to set up authentication with AAD, I can start doing that here as well. But let's go ahead and publish this application. And as you can see, we get the option to publish this directly into Microsoft Azure App Services. I'm going to select an existing one. I already set those resources up. I could also create new resources directly from within Visual Studio if I wanted to. Again, Visual Studio is connected to Azure, and it shows me the available resource group, the available app services that I have. And I can go ahead and now can I deploy this application, which is set up to be monitored by Application Insights, which needs a SQL server for my user profiles. And as you can see, we now started web deploying this application into Azure. So let's go back over here into the portal. And here you have the app service resource. So there are many ways of running code in Azure, and let's probably get a little bit back to this. And app services is the way that you can just easily run any ASP.NET web application. You can also run something we call web jobs, which is basically a working process that sits in the background and is doing stuff. We have new services such as Azure Functions, which is those call them serverless architecture. It's just small methods you can run and call via REST APIs. If you, for some reason, need it, you can set up a virtual machine, and you have a server you can run anything in. We also have the concept of virtual machine skill sets, where you need a multitude of machines that are alike, and you run some stateless workloads on top of those. So it's an easy way to just create a lot of servers that are alike to run your application and run your code in Azure. So we should be done publishing the application now. And here you have the URL to my application in Azure. And there you go, we have a runtime error, that's nice. Let's see if it actually comes up. Maybe we were just too quick getting into that application. So there you go. Here you have the ASP.NET MVC standard application that we deliver as a template in Visual Studio. And just to show you that we actually do have the SQL Server backing this up, I can go and register a user into this application, which will then register the user account in SQL Server. And you can see that we have all that connected. We actually have a web application. We have a SQL backend, and we can just create we can start creating our application from here on. Probably doesn't care about the email being right. So there you go, and I should now have this account registered in the SQL database in just a few seconds. So you can see I'm now logged in, I have my user registered. Okay, so I didn't actually time it, but I think it was about 5 minutes. We created the web application using the template. We set it up to use a SQL Server. We had those resources in Azure. We could have created them as part of the publishing process. And now we actually have a full-blown ASP.NET web application and SQL Server in Azure. Easy, and we have the application insights monitoring enabled as well. So let's go a little bit deeper on the diagnostics part of this. 3 features I want to highlight, and hopefully I get time to show all of them. We have something we call the application map, which is an easy way to show how your application interacts with other services and depend on other services. Where we recently added a feature about automatically correlating requests between services. We have something we call the snapshot debugger. The snapshot debugger in Azure, I briefly mentioned earlier. We're actually able now to go into production and do snapshots of exceptions that are happening while your code runs in production, which gives you these debug sessions that you can go, packages you can go and download, and then you can do a sort of an offline debugging in Visual Studio locally. So you actually see how the application behaved at the point in time where this exception occurred. And finally, I just want to quickly show you the Application Insights Profiler, which is a tool that helps you find potential scaling issues, performance problems in your applications as well. So let's just do this the demo way, and let's start over here. So this is the Azure portal again. As you can see, I now have a different dashboard. This is called the Visitors Snapshot Demo dashboard. And this is a dashboard that one of my colleagues created. He shared it as a resource in Azure, so we now a lot of people that have access to this dashboard, and we can sort of, party on. You can see the different dashboards I have here. And we can start partying in this application, just help figuring out what's going on, because we obviously have a lot of errors there. One thing to notice is that we also provide sort of dashboard tiles and widgets to show you the actual resource consumptions of resources that we're using for this application. But let's start with the application map up here, as I just mentioned. So this application map is something that we generate for you automatically. So if you just enable application insights, oh, let me get back, sorry. If you just enable application insights like I did in the previous demo, you have this. There's nothing else you have to do. You don't have to go paid tier. You actually don't have to do the last 17% as well. You can, 83% is enough. And what you can see here is that this is my main web service in this diagram. And I have some availability monitoring that I set up in Application Insights. This is a thing I can go and do once my application is up and running. So I can have Azure monitor my application from, I don't exactly remember, but it's a lot of different locations around the globe. And then you can see how this web application that I have has dependencies on a SQL server It has dependency on another web service. And there's also some arbitrary HTTP calls, which are basically HTTP call that sort of goes out of whatever resources I have that are monitored by Application Insights. So let's see how this could become useful for us to figure out what's going on. You can see we have 99.8% failures on this guy down here, which is another web service that I have. So this is web service 1 calling web service 2. And if I start digging into this, you can see I easily get this view of the top arrows going on in that web service down here. And I can try just looking into one of these exceptions. And you can see you get exceptions messages and everything directly within the portal, which is fine. But what is the new thing we added and what's very helpful in a scenario like this where you have these multiple services like a front end or a back end or a middle tier, whatever we should call them, calling, is that I can actually see telemetry for what we call the operation, sort of the end-to-end flow. So what I'm getting on my right-hand side now is different telemetry points or monitoring points that Application Insights picked up for me. And you can see that I had a request coming in to my web application here, so the web application. It made a dependency call to the CRM service, which was my other service. And I also added some tracing just to make it easy to understand. So I'm saying, oh, I'm in the front end now, and I'm about to call my back end. And then you can see the request coming in on the back end. You can see, oh, I'm in the back end. I'm about to call the back end. I don't know who wrote that, but that is what it is. And then you see the actual exception occurring up here. So you get this full lens from the very first entry request coming into my first web service, what's happening all the way through, and how it ended up to be an exception on the, I think, calling the database in the end. And again, this is thing you just get for free. And not only free in terms of you don't have to pay, but you just had to do that configuration in Visual Studio. And these things are just set up for you. So this kind of diagnostics doesn't require any specific configuration or anything. Just run your web app in Azure, and you get these great diagnostics features. The other thing I want to show you is the snapshot debugging. So let's try to look at this other web application where we have another failure in this guy, which is some index out of range exception. And you can see the setup here to do snapshot debugging. So what I can do now is by clicking this this link up here, I get actually call stacks and I get local variables directly in the portal. What I also can do is I can go and download this snapshot. I think it's a few hundred megabytes, 150 megabytes, something like that. So I already went ahead and did that to not do it as part of this talk. And what I've done now in Visual Studio 2017 is I've opened up this, you can see up here, it's called this DIAX session, that's just the file I downloaded. I just clicked that link, I downloaded this file, put it into Visual Studio together with my source code of my application, and I can actually now debug, so to speak, locally what happened in the cloud at that point in time. And immediately Visual Studio pops up and tells me this is the line of code where the exception occurred. And what makes it easy for me is I have all the variables available to me. So in this case, we're just trying to format a new string based off 2 parts of another string. The only problem is that the string we're trying to take out the different parts of doesn't have anything, because we tried to split it with a punctuation, and there was no punctuation in that string. It was just an empty string. So the exception that occurred in production, I can actually go ahead and I can do the debugging locally, even though that this was code that ran in the cloud. And it gives me an incredibly easy way of troubleshooting production issues like this. If these diagnostics features are something you want to learn more about, my colleague Paul has a talk after this session where you go deeper into all of these cloud diagnostics features. Some of the things I showed you here explain a lot more about how they work. We also have things called snap points and lock points, which is where you can sort of stream these kind of snapshot debugs directly into Visual Studio from a production environment. So actually, while things or errors are occurring, you can see those directly into Visual Studio. And the reason why I'm showing you this is just and I want to just analyze again, you just run your application in the cloud and you just get this, right? Just imagine what you would have to do to get features like these set up in your local environments today. The configuration, installation of third parties and other things you have to set up together with your web application. Adding application insights, like I just showed you in Visual Studio, running things in the cloud, you get all of these diagnostics and debugging features for you, which I think is a great as a developer to get all that insight. So the last quick thing for the diagnostics is the profiler. So here I have a web application that I run in Azure. It's called Fabricam Fiber, and I can click around this web application, and sometimes this ticket thing takes a little while to load. And maybe I want to go ahead and do some forensics about what's actually taking time in loading that application in production, or that specific page. So I have another application insights resource set up here, and as part of this, we have this menu item in application insights, or this feature where we go and do some performance analysis of your application. So on the right-hand side, you see some metrics about server response times, dependency response times, how many server requests going on. And you can zoom in on these timelines and adjust them and see the details there. And you can go in and you can do some very detailed analysis, querying the individual diagnostics information we have. But what we also added with the service profiler, and this is the feature where you need the paid version of application insights to actually run this, is that we go and do we go and take example executions of your code, and we analyze those for how long it actually took to execute a specific code path in your application. So in this case, you can see some of the operations within my application we have fairly high count of. So this is something that's run fairly often. We have others that aren't run fairly often. And you can see the different times for the median and the 95th percentile for how long it took in milliseconds to actually execute these operations. And when you dig into these examples, you can actually go and see some of the individual executions of those operations within your code. So if we go down and we take this is one of the fast operations that we have. We sort of highlight here the hot paths of trying to help you to focus on what it is that makes this call be, well, where the execution of this operation takes the longest time and the most resources. So you can see there is some execution of the CHTML rendering the view start. And I think there is a scenario in here. As you can see here, we have a hot path. We're actually spending almost half of the time. You can see the total execution here is 477 milliseconds. We have 220 milliseconds. We're actually going out to an Azure blob storage. So we're going out to storage to fetch some resources for some reason here. So it gives me good insights if I need to scale up my application at one point in time to be proactive and figure out where I might have issues when scaling this out. So in this case, for instance, maybe accessing the storage account to get these resources isn't a good idea. Maybe I should implement some local caching close to my service, and other scenarios that you can go and identify just using this profiler. So again, I think the takeaway for most of you is it's just there. It's part of running this thing in Azure. It's part of using application insights, and it just enables you to get insights and debug and troubleshoot your application at, I would say, almost at a different level than what you're used to. And again, go to Paul's session after this, and you get some more insights in the whole diagnostic story. Okay, so 3 cool diagnostics features. App map and correlation. You can see failures, you can see executions. Snapshots to do debugging locally. And finally, the profiler to help you find scaling issues and performance issues with your application. So the last thing I want to spend some time on here is some concepts you probably all heard about. Some of you have been doing something with. So containers and microservices, which is, I would say, which are 2 things that are sort of becoming de facto for building higher scalable applications in the cloud. So let's talk a bit about this, and let's start about figuring out what's the whole deal about these things. I want to tell you a little bit about Azure as the platform for running microservices. And then I want to show you in the end how you can use containers to easily modernize a .NET 4 application, moving a .NET 4 application from any data center into the cloud by using containers. So how many of you use, let's start with the microservices part. So why do we want microservices? So the whole idea about microservices is that we try to break down our application into small pieces. And as you saw from the app map before, where I had like 2 different web services sort of being part of my application, sort of a front end or a back end, is sort of a way of isolating those individual domains within my application into individual service, so I can sort of deploy them individually. I don't have to deploy them as a monolith all the time. I can change them, and by that means I can continually involve this application by adding new functionality, by adding a new service, not by changing existing application code that I have. So it gives me faster delivery of features and capabilities, and it also gives me the opportunity, especially in a cloud world where everything is web and sort of HTTP is the standard of how services communicate, that I can use different technology stacks. So if you could imagine a web application or a web shop, we actually have a great sample of making e-shops microservices, where the service that handles the cart and the checkout might be some back-end .NET Core service or something like that, that part of my team or a few developers wrote. And then there is a front-end API that's written in Node.js with some other parts of the team wrote, which runs as another service, another website. So it gives you this ability to have different technology stacks across the whole application. And it just makes it easier to build and operate a service at scale. Also scaling the different parts of your applications individually. Like if you had one application that always needed to scale together, and you needed more resources to run your application, as opposed to being able to scale just, let's say, just the cart service of your web app, or the search service of a specific website. So that's what microservices are good for. They're good for running high scale, they're good for running in cloud, they're good for agility. And what containers are for is, so how many of you are using containers today, in some sense? Very few. Just is production workloads? Yeah. Okay. So what are these containers and why are they together with microservices, and what does that mean? So first of all, containers is this. So container is a way to create sort of an immutable image of your application and all its dependencies. So thinking back at the web application I just created in Visual Studio, and we deployed into Azure, we use the web deploy feature in Azure to do that. So basically what that means is that I run I run a publish command on our web application. It creates a directory with all the files needed to run my application. And then I can go and take that and I can put that into this environment where I already have IIS running. So all the dependencies that my application have, which is IIS and the operating system and configuration and everything, is already set up in that environment, which enables me to take that application that I just published, which is just a directory, and put it in there. Now, if this was a container, what I could have done instead is I could have built everything as this image. So instead of just having a folder with my application files, I would have a container image, which is my operating system, it is my IIS and configuration, so the Internet Information Server, and it's also my application code. So what I move from Visual Studio and into my service is that whole container thing, which contains everything. So there's no dependencies on having the environment being configured in a specific way. I just have to have my environment be able to run a container, and I can move anything in there. So this thing about, so that's what, when I talk about an immutable image, that's what I mean with that. So it enables this mantra that because it works on my machine, it works anywhere, because it's the same thing I run. The whole OS, all the dependencies and my application. It's not my application going into a foreign environment. I have everything in that container. It also eliminates problems with conflicting dependencies on hosts. So let's say that I've used a specific third-party component in my application, but I have multiple applications hosted in the same server, And those applications had to use different versions of that component, and that component couldn't be installed side by side. Well, because I bring everything in my container, also those dependencies, I can actually now run those side by side. So conflicting dependencies on host is another thing that containers can help you eliminate. And then because everything is in the container, it's a unit that's very easy to deploy and orchestrate. So once if you have this, going back to this idea of microservices being these small things that you could easily scale and move around, if it's a container where everything and all dependencies contained within, it just makes it even easier to build an application based on these small, immutable, deployable units. So it's easy for me to fail them over. It's easy for me to scale them up individually because I can just move them into anything and they bring all the dependencies with them. So it actually becomes, and it makes containers this great deployment vehicle for microservices. I don't know of a better term of saying that. So I think the main point I want to get to you when you talk to people about microservices and containers, and when you're being asked about microservices and containers, is that it's two different things. Containers are great. It's a great technology to help you achieve building applications based on microservices or using microservices. You don't have to use containers to do microservices. You don't have to use containers to do anything. The scenario I showed you with deploying a web application using SQL, using SQL in Azure, running as a web application SQL, didn't use containers and doesn't have to. It's an easy way of getting that one application up and running. It's a very cost-efficient way of doing it. But once you get to a certain scale and you want to do this cloud thing, containers can help you achieve some of the things you want to do with scaling out and building microservices architectures. So what can those microservices be in your application? There are sort of two main themes here. There's one thing which is what we call the simple complementary microservice. And the idea is this, that you have a little bit of code, a simple function or operation that's sort of part of your overall application system or architecture. So for instance, you could have a mobile application where you have a REST endpoint that you talk to, and you have a SQL database or some other database where you store your data. But then you also have this function to do something with incoming requests. So that function could be your microservice within that application design. So let's say the function is a thing that, I put in a request through my mobile app, it's doing something with the REST endpoint, it ends up putting a message on a queue somewhere, and someone needs to go and pick up that message, do some work, and maybe process a notification or whatever that could be. You could have a function being that code that's doing that part, picking up the message from the queue, doing its thing, and sending up a notification. That could easily be defined as a microservice. It's a small piece of code. You can easily change it independently of having to deploy all the other parts of your application. And because Azure has these high-level services like functions where it's easy to just run one specific piece of code, that's one way of having microservices part of your application. The other thing is the complex microservice architecture, and this is extremely useful if you want to build, or if you have to build like easily scalable, and specifically if you have the need to scale globally, or just high throughput of information you need to process as part of your application. You can build out your whole application with microservices in mind, use the different technology stacks for different parts of the application, having it all implemented as containers in this easy deployment model. And we have some great Azure services as well that help you run those kind of applications. So talking about the Azure as the platform for microservices. There are these three services I want to highlight. So I mentioned functions a few times, and this might be a little too late, but how many of you have heard about functions before? Okay, it's a fair amount. So the whole idea about function is that it's what we call serverless and event-driven. So serverless compute and these simple microservices. Basically what it is just a piece of code that you tell Azure that if I call this function, run this code. That's it. That's all it is. So again, in the same scenario with the web app before, I just put a web application up in Azure, just run there. I can just put this simple function up there, and it's just being executed based on the events that I define. And I can have multiple functions work together. If you think about services like if this, then that, if you know that service, where you can sort of hook together a lot of web services, like I get a mail from my boss, send me an SMS, send me a text message to let me know, or whenever I get an email from this guy, just post this on Facebook. You can set up those things in these kind of services. These services are sort of based on these principles of having sort of individual functions that you chain together to accomplish these things. So when you create Azure functions, you put this simple piece of code into Azure, and it just runs based on the event that you define. Then we have the microservice and container platforms in Azure, which is Azure Service Fabric and Azure Container Service. So Azure Container Service is a way that we provide you with great container orchestrators, all of which are open source, but which we found a great way to run on Azure, and we help and support you in doing that and make it very easy for you to set up and configure. So a container orchestrator is a cluster. So it's a bunch of virtual machines you run in Azure, and they understand how to run containers, and they understand and give you great tools for easily scale containers and fail them over. So if I were to put a web application in a container, I can go and host that in a container orchestrator, and the orchestrator can then help me run that container in one or multiple instances, fail them over when nodes go down, or I need to take node down for maintenance. And it helps with service discovering where containers live, routing traffic to the containers, and those kind of things. So Azure Container Service is a way of running containers, different container orchestrators, open source container orchestrators in Azure. It's Linux mature. It's also Windows mature now, actually, with the Docker Swarm as being one of the orchestrators you can run there. And then we have Azure Service Fabric. How many of you have heard about Service Fabric before? Some of you, any of you developed, coded anything with Service Fabric? A few guys? Okay. So Azure Service Fabric is a Microsoft application and orchestration platform. Azure Service Fabric is actually what Microsoft used to run a lot of our services in Azure. So if you're using Azure SQL database, if you're using Cortana, if you're using DocDB, the new Cosmos DB, a lot of the Azure service, the way that Microsoft built these services is actually using Service Fabric. So Service Fabric is the thing we've given to you to help you create large-scale services. So there is an application programming model that you can use to easily create microservice architecture. And it also just orchestrates containers like any other container orchestrator. It actually orchestrates any process. So you can run any executable within inside a Service Fabric cluster, and you get all of the failover and scalability features that you also will get if you run containers in there. So these are the three services I want to highlight for running microservices in Azure. So I want to spend the last time taking you through a scenario of where you actually want to containerize or put a .NET 4 application, it's actually an ASP.NET 4 application, into a container to put you on this path of start modernizing your applications and how you can use the cloud to do that. So the sort of graphics I have in the bottom is trying to explain how you get from this solid cube of sort of interconnected functionality and operation you have within the application, also sometimes referred to as a monolithic application, and how you can, by, in this example, moving into containers, into Service Fabric, start breaking it out or adding new functionality and start using things like microservices and containers to help modernize the application, help giving you some of the benefits that these patterns give you, like consolidating workload with containers in orchestrators, giving you high reliable, high density platforms, and then of course giving you all the modern cloud DevOps of easily scaling and deploying these applications. And finally, maybe even turn your application into a real microservices architecture application. The whole point about this is that you can take this as far as you need, as far as your business needs you to take this. So let me just show you the very basics of taking an ASP.NET 4 application using Visual Studio tooling and bringing that into the cloud in a container to help you start, get on this path. So what I've done is, first of all, I have a tutorial I'll show you the link to these resources. And this tutorial actually takes you through the whole demo that I'm just gonna rush through right now. I don't think we can get to everything. Tells you how to get set up with the local tools you need to start doing containers and debugging locally and move things into the cloud to take these .NET apps and start containerizing them. So I've taken one of our ASP.NET samples that we have today, which is called the Fabric and Fiber. Actually, it was the one I showed you before, this thing here. It's just an ASP.NET MVC application. And if this is not running, that's fine. Okay, it's just an ASP.NET application that I have. I also have it here running in the cloud. It's an MVC application. It's a very simple web application actually that runs out there. Now what I want to do is, it's an ASP.NET 4 application, and it needs IIS, it needs a web server to run. So the typical scenario today is I would take this application, probably together with some other web applications, and I'll start hosting them in IIS in my own data center. Many of you have web applications running in IIS today. Few of you? Some? Some have? Yeah, okay. I can see the answers like, no. Okay. And you know the deal with IIS and deploying, and if you have clusters and you need to load balance and everything, and when you deploy, you need to, there's a lot of stuff, and you need to make sure you got all the dependencies and everything. So this is one of those applications. What I can do with Visual Studio 2017 is we added something we called container tooling, which just makes it very, very easy to start creating containerized applications in Visual Studio. So there's something here called Docker support. And whenever I've set containers, until now, it's sort of a container is like a concept of doing things. Then there is an implementation of creating containers, which is called Docker. So Docker is an open source format for creating these container units. It's also a company that's building services around this. But Docker containers is just an implementation of containers. It's the most popular. It's sort of becoming the de facto of how you do containers. And that's the thing we support in Visual Studio with our tooling. So I can add Docker support to this web application. And what we're doing then is we're setting your project up and giving you the specific files and the artifacts you need to actually wrap this web application in a container. And there are two things here that you need to know about. First of all, there's something called a Docker file. And the Docker file becomes part of your project. And then we have something called Docker Compose, which is a new project that we introduce in your solution. The difference between the two is that the Docker file describes how we create that container image, the sort of the unit that we can move around and deploy. What's inside that? Whenever I build the image, how is that being built? The Docker Compose file then tells me if someone should run this container image, how should it be run? So Docker file is how I build my image, and Compose is how I run my image. So as you can see in this Docker file here, I have these different from, arg, work, dir, copy, other kind of declarations I can put in there. The most important part is actually the from statement. So the way that these container images work, it's sort of a layered technology. So you have one container image that you can reference, and then when you start to build your own container image, you layer on top of those images that are already created. So one of the images that we as Microsoft publish is one called Microsoft ASP.NET, and there's a specific version of that, 4.6.2. If you reference that image when building your own container image, you get a Windows Server Core 2016 with IIS and ASP.NET enabled. So that's actually a base container that's ready to run your ASP.NET 4 applications. Visual Studio identifies that I had an ASP.NET 4 application here, which is why it creates a Docker file and setting me up to do that. And then we're doing some stuff with just copying the application inside the image, which is what we do with the copy command, and we set the working directory and so on and so forth. These images are all publicly available. They're documented on GitHub. But for now, the tooling just gives you what you need to actually get this application running. And finally, just to quickly show you the Compose file. The Compose file works in a way that it specifies basically which container image to run. So you can see that we create a container image, the one we described in the Docker file, which is going to be named the same as my project. And then we're just going to build and run that. That's basically all we do today. So I already had this up and running over here. So yeah, my debug session. I actually started a debug session up front because Windows container images, they're not small. I mean, if you have to put a Windows operating system inside a single file and move it around, it becomes fairly big. Typically, containers in the Linux world are megabytes, so they're very easy to move around. When we're in the Windows world, it's gigabytes. And it's just how it is, and we're working on something called a nano server operating system to make, specifically to make smaller container images available. But there definitely is a use case where you want to take these older ASP.NET applications and use containers to move them into this modern world, where even though that Windows containers are in the tens of gigabytes, I think it's 10 gigabyte actually, containerizing them makes a lot of sense in those consolidation and modernization roadmaps. And just be aware, because container images are layered, as I just told you, the base images, when you deploy multiple containers using the same base images on any node or VM, you don't have multiples of those base images. You only have it once, right? So that sort of takes the top of the whole size discussion there, if that's the thing. So here you see I'm actually able, even though I run in Visual Studio locally, it's one of my first points in my presentation, we give you a great local developer experience for anything. So this is now that ASP.NET 4 application running in a container. It runs in a container locally on my machine, and I can browse around it, and I even have breakpoints set. So even though I run my application now in a container locally, I get what you would expect from any project or application type you run in Visual Studio. You get debugging. You can even debug cross containers if you have multiple containers that you run. And there's another little secret piece of what I've done here, is that usually when you do ASP.NET applications in Visual Studio, you use local DB, which is a specific SQL Server DB implementation that just gives you SQL Server locally. I've actually set this application up so that I'm running a SQL Server in a container as well. And you can see that here. So this Docker Compose file that tells me how to run my container, I can specify multiple containers as part of that. So you can see there is a concept there in line 3 called services. And then in line 4, we have the Fabric and Fiber, which is my web application. And in line 9, we have the database image. So I actually run SQL Server in a container next to my web application locally. And we can do all that, and we can, by using these declarative formats in Docker Compose, we can make those work and we can connect together. So that's how you get a local developer experience and how you get from just having an ASP.NET 4 application now actually running it in a container. And when this becomes really powerful is once you have this up and running in Azure. And what I'm going to show you here is I have my container now, my Windows. Because these are Windows container, I've chosen to deploy them into Service Fabric. Service Fabric is, I think it's the only service today that has general availability of running Windows containers in Azure. So Service Fabric, again, is this cluster. It helps me run things at scale. It helps me fail over and give me great reliability of my applications. This is a cluster consisting of 5 virtual machines. And Service Fabric has its own Explorer management interface, which I'm going to show you here. But what's important and what I want you to notice and what I really want you to see is you can see this is my container now. This container has an ID in here. But trust me, it's my container. It's the web application. It's the one you have here. It's running in Azure. What you can see is I have one instance of this running in my cluster. Now, because this web application is now containerized, and I have this container orchestration technology, if I wanted to have multiple instances of this container now, let's say I needed 3 of these web applications, it's as simple as telling the cluster, now just run 3 instances of this container in the cluster, and you can see immediately I have 2 more instances being spun up on 2 of the other nodes in my cluster. So for those of you that have web applications running in IIS locally today, just imagine if you had to do the same with that application in your data center. Like, just give me 2 more servers and add this to this across a web farm. Because things are containerized and we have the container orchestration technology, it is as easy as this. What I can also do is I can say, well, this node number 0, that I have in my cluster, for some reason it needs to restart, or I just want to restart it. Let's see if I can get to this guy. Yeah, there you go. So let's restart this node, and just what I want you to notice now is that because my cluster knows that it needs to have 3 instances of this application or this container running, because that's what I told it, you can see that this one instance now, as node number 0 is restarting, is now going away because the node is down, and boom, another container comes up on one of the other nodes. So even for these failover scenarios or maintenance scenarios that I have to do around my applications, having my applications containerized and using cluster technology gives me this very agile way of running and operating my containers. So one thing that I didn't get to with the containers is the whole CI/CD part. But going back to the tutorial that I showed you, which is the number 4 here, the ASP.NET 4 containers, it will take you through all of that. As I said in the beginning, Visual Studio Team Services has all the basic building blocks of creating containers, deploying into Azure. It's definitely a tutorial worth going through if you want to just get started and figuring out what containers are and you're used to ASP.NET 4 applications. It's a great way to get started, and actually leaps you forward into this world of starting to be able to use containers and seeing how this fit into the microservices architectural patterns and all those. Email, Twitter, reach out if you have any questions. Also, I'm here available now to do questions, and I'm also part of a workshop going on tomorrow, if any of you are attending that, for building cloud applications, modern cloud applications. Thank you, I hope you enjoyed it.